Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
So, good morning, participants. So, let us start the session for today. So, yeah, we were dealing with this diabetes data set, right? And what did we cover till now? We covered the EDA part. We covered the EDA part. And after this, we are now going to check which model is going to work best for the data. So, currently we have checked with logistic regression, and the other one is the decision tree classifier. Let me give you a brief idea about what is the working principle behind logistic regression and decision tree classifier. Okay, so what happens in logistic regression? Okay, so logistic regression is going to work for a classification problem. So logistic regression works for a classification problem. That means you are trying to predict the class, you are trying to predict the, just give me a moment. Yeah. Your logistic regression is going to be a classification problem, and it means that the output that you are trying to determine, is pointing to some categories, or you can say it is pointing to some class. Okay, that is what classification problem entails. Now, what happens in the regression model is this, that it is going to have the set of the independent features, suppose x1, x2, x3, and x4. And using these 4 independent features, you have to now find out how this is affecting the y. Suppose because of some value here, 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 and here, the outcome of y is yes. Because of some value here, here, like this, the output is no. Like this, you have no, no, yes, and like this, the whole outcome variable is going to be having some values. Now, when you apply the logistic regression model to this data, what happens is the logistic regression model is going to learn how x and y, that is the set of independent feature and the dependent feature, how they are related. Okay, so ultimately, once the model has learned these patterns, it is going to see what, once the model has learned this pattern, it is going to now try to predict. It is going to now predict because it has now trained, right? So the prediction is going to be in terms of probabilities. The prediction is going to be in terms of probabilities. Okay, so all these yes, no, 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 yes, they are going to be represented as what? Zeros and ones. So y is going to be given 1, 0, 0, 0, and 1. Now, if the probability value on prediction is coming to be somewhere around 0.7, then it means what? It is closer to 1. It is closer to 1. Then what is going to happen? The output is going to be predicted as 1. If the probability predicted is what? 0.3. That means what? This value is closer to 0. So it is going to be predicted as what? 0. So the logistic regression determines the classes, whether it is going to belong to 0 or 1 by looking into the probability values. So if the probability value is greater than 0.5, then it is going to go for class 1. Otherwise, it is going to go for class 0. Otherwise, if it is greater than 0.5, then it is going to predict as class 1. If it is less than 0.5, then it is going to predict as class 0. This is how the logistic regression model is going to work. Okay, this is how the logistic regression model is going to work. The next one is what? It is the decision tree. decision tree. Now, decision tree, this concept can be used both for a classification problem and it can also be used for the purpose of regression, both for classification and regression. When you are using it, when you're using this model for the purpose of classification, then from sklearn, you have to import the decision tree classifier. And if you are using it for regression, you will have to call upon the decision tree regressor. Okay. Since the problem that we are dealing with the classification problem, we are going to call the decision tree classifier. Okay. Now, how does the decision tree works? So let us have a look. Suppose I have x1, x2, x3, and x4. And these are the independent features. That means using these features, you have to determine y. Y is your dependent feature. It is the outcome feature. Okay. Now, what happens in decision tree is it is going to construct the tree-like structure. So, what is a tree? A tree is going to have some roots. Then it is going to have some branches. And finally, it is going to have the leaves. Not a very good drawing, but I hope you get the idea. Now, the tree principle in case of the decision tree works similar to this. Only you are going to invert it. That means at the beginning, you are going to have the roots. Then you will have the branches. Okay. And finally, you are going to have the leaves. Okay. So this is how the decision tree is going to be constructed. Okay. So let us see now what happens actually. So the decision tree classifier, online participants, can you hear me? Yes? Okay, okay, great. So I got a notification here saying that my audio device was failed to connected. So that's why I asked. Okay, fine. If you can hear me, then that's great. Now see here, what happens in the decision tree classifier is, first it is going to identify out of these 4 independent feature, which feature is best for the root node. Which feature is best for the root node. After that, suppose it found out that, how is it going to check? First, it is going to create x1 and then it is going to make a split. x2, then it is going to make a split. x3, then it is going to make a split. x4, then it is going to make a split. That means using x1, you have split the entire data set into 2 parts. One part here, one part here. x2 also you have split it, one part here, one part here. x3 also you have splitted the data in like this. Okay. Now, the decision tree is going to find out of all these splits, which particular root node or which particular column, when considered as the root node, was giving us the most pure nodes. It was giving us the most pure nodes. Okay. So I'll just highlight it with a simple example. Suppose I have x1, x2, and the outcome variable is like this. Red, 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 blue, and blue. Okay. Then x1 is suppose 10, 20, 30, and then I have 40 and 50. Here I have something like this. 100, 75, 25, 55, and suppose 65. I have something like this. Now see, now what decision tree is going to do, here I have what? 2 independent features and I have the dependent feature y. So what the decision tree is going to do is, it is going to first identify, okay, let me take x1 And using x1, I am going to make a split in the data. So what is the criteria of split using x1? Suppose the criteria of split is what? If x1 is greater than 30, then it is going to make one split. If it is less than 30, there is going to be another split. So this is for yes, this is for no. So is x1 greater than 30? So how many of it is satisfied? x1 greater than 30, this one, and this one, right? Sorry, x1 greater than 30 is 40 and 50, these two, right? That means what is the outcome of this? B and B. B and B. Is x1 greater than 30? No. Then what are the three nodes then? 10, 20, and 30. So what are the outcomes? Red, red, and red. Okay. Similarly, you need to find out for x2 also. So for x2, what is the splitting criteria? Suppose for x2, the splitting criteria is this one. If x2 less than, if x2 less than, if I take 100, if x2 greater than 100 or less than 75, then I have red on one end, red and red, B and B on the other end. If I take, if x2 less than, sorry, if x2 greater than 25, then I will have what? I will have red, red, blue, blue on one end, and I will have red on another end, because this is the only thing coming here, and the rest, everything is going here. Now, tell me, out of x1 and x2, who is giving you pure nodes on the child nodes? These are the child nodes, right? And who is giving you the pure split? Is it x1 or is it x2? Who is giving you the pure split? Here, this is not a pure split, right? You have a combination of both categories. So x1 is giving us the pure split. Pure split. So that means x1 is going to be the criteria for the best split. Okay. x1 will be the selected as the criteria for best split. So x1, and using x1 you found two nodes. Now suppose after splitting you found this is non-homogeneous, that is impure, and this is pure. That means here also you will have to make a split. So again, it is going to be checked out of x1 and x2, who is going to give us the pure split in this node. Again, it is going to be splitted further. So this is how a decision tree is going to be constructed. Okay. So suppose, say I have something like this. Let me just resolve this. Suppose I have now like this x1, x2, x3, x4, and y. So what happens is, suppose using x1, we found that it is going to give us the most as pure as possible nodes. So this is going to be split. Okay, this is going to be split. Then at this region also, what is happening? There is some kind of impurity. So again, suppose using x3, there was another split. Then again, here there was pure node, here there was pure node. Again, in this region, there was some again impurity, which means again, suppose using x2, there was another split. Okay, so this is how decision tree is going to keep on splitting unless and until we have a pure nodes at the bottom. Unless and until we have pure nodes at the bottom. Okay, but if we try to keep on building the tree deeper and deeper and deeper, if we try to build the tree deeper and deeper, we might face a situation which is called as overfitting. Okay, we might face a situation which is called as overfitting. That is why we do not build decision tree for the full depth. We do not build decision tree for the full depth. Okay. What we do instead is we try to cut the tree in middle. We try to cut the tree after some expansion. That means, suppose I'm saying keep the depth of the tree as 3. That means it is going to make a split here, then it made a split here, it made a split here, and then it made a split here. Okay, now see here, I'm saying depth it should be limited to 3. So this is 0, 1, 2, and 3. So this is how the depth is going to be decided. Now at this point, suppose there are impure nodes, but since I have limited the depth of the tree as 3, this node is no longer going to be splitted. Okay, so this is what we do. This is your decision tree classifier. Now, we also have another classifier which is known as the k nearest neighbor classifier. Okay, so the working principle, I'm just giving you a brief overview how it is working. So what k nearest neighbor is going to do is, it is going to look into the neighbors. That means output will behave similar to neighbors. Okay, output will behave similar to neighbors. Suppose I have some data like this. Suppose I have some data like this. Okay. Now, what I will do is, suppose I am considering a data point here. Suppose there is a data point here. And I have to find out what is its output. Is it a plus or is it a circle? So I'm going to say that I want to check its closest 3 neighbors. I'm going to do what? I'm going to check its closest 3 neighbors. So what will happen? The distance of every single point will be calculated to this point. So distance from this point to this point, distance from this point to this point, this to this, this to this, this to this, this to this. So distance from, so let me write this as what? P. Distance from P to every other point will be calculated. Distance from P to every other point will be calculated. And I have chosen what? Closest 3 neighbors. I want to find out what? Closest 3 neighbors. And calculated, and the 3 points having lowest distance is going to be selected. It is going to be selected. So what? K stands for what? K stands for the number of neighbors. So I'm saying what? K equals to 3. So suppose I found out that this, and this, they are the closest neighbor to P. Okay. Now, out of these 3 closest neighbor, which is the most occurring value? It is the 0, right? It is this 0. So 0 is going to be the class of P. 0 is going to be selected as the class of P. Okay. So this is how the K nearest neighbor is going to work. If I say I am going to consider K equals to 1, and suppose it was found that this is the closest neighbor to P. Now, since I have selected K equals to 1, that means P is going to be assigned whatever value the closest neighbor has. So the closest neighbor has a plus symbol. So P is also going to be assigned the plus symbol as the outcome. So this is how K nearest neighbor works. Clear till here, everyone? So this is the third type of classifier that we have in machine learning. Then we have support vector machines. support vector machines or support vector classifiers. So how do they work? Support vector classifier works by introducing a decision boundary. It works by introducing a decision boundary between different categories. Okay, between different categories. So support vector machine is going to work somewhat like this. Suppose I have a three-dimensional data. So these dots are lying on the top and these plus symbols, they are lying here. Okay, plus symbols are lying here. So what support vector machine is going to do, it is going to introduce a decision boundary, or in this case, we call it as the hyperplane. Okay, so it is going to introduce a boundary like this. Okay, so this boundary is going to serve as the hyperplane. So anything which is lying on top of the hyperplane, they are the round points. Anything which is lying below the hyperplane, they are the plus point. Okay, so when you are dealing with the three-dimensional data, then the hyperplane is going to be of 2 dimension. If you are dealing with a 2-dimensional data, suppose you have data like this, and what happens is here the separation boundary, here the separation boundary is a single line. It is a single line, right? So this line is going to be the hyperplane, and this line is what? It is a 1-dimensional boundary. Okay, so when you are dealing with n-dimensional data, then the support vector machine is going to construct a hyperplane which is of the dimension n minus 1. Okay, n minus 1. See, in this case, if you have a 3-dimensional data, the plane generated is a 2-dimensional plane. If you are dealing with a 2-dimensional data, the plane generated is a 1-dimensional plane. Okay, so this is what the support vector machine is going to build. Okay, so let us now try to construct these two, the k nearest neighbor and the support vector classifier. Okay, so in yesterday's this one, we built all this, right? So we have now discussed these two new things. Let us try to execute them. So see here. Okay. So what I will do, now I'm going to try to build a KNN classifier. Okay, so in order to do that, I have to first import the libraries. So from sklearn.neighbors import what? K neighbors classified. K neighbors classified. So that's the beauty about Google Colab. You write 2 letters and it is going to give you the prompt. And like if you are confused, like should it be small and capital N, then you can simply select this prompt. Okay, so from sklearn.neighbors, import the K neighbors classifier. The next step is we are going to initialize this model. Suppose M1 is equals to what now? K neighbors classifier. Now here I need to specify how many number of neighbors I want to consider. So I will say what? N equals to, I want to consider 7 neighbors. I want to consider what? 7 neighbors. And then after this model is created, I have to apply this model to the data. So M1 dot fit on what? X comma y. X comma y. Is it x comma y? Yeah. Oh, let me just use cross validation technique here. Okay, I'll do the evaluation using cross validation technique. So RES is equals to what? Cross val score on the model M1 comma X comma Y. CV, I'm going to keep it as 5. And the result is going to be what? RES dot mean. Why is it coming as error? Let's find out. Just let me check it once. Mhm. Yeah, so I made a mistake here. I should have written what? N underscore neighbors. See, the prompt is showing me the mistake. So what I will do, N underscore neighbors equals to what? Set. Control enter. And now I have the data. So what is the value of the accuracy? So accuracy value is coming to be somewhere around 73.5%. So what I will do, I'll store this result in this list. I'll store this result in this list. So m.append model, which is your ANM, and s.append, that is the accuracy value, which is R. Control enter. Now if I try to see it, print m comma s, I'm going to see that I have both logistic regression, decision tree, and KNN. I have all these three models with me. Okay. Now the next thing is what? Similarly, I'm going to execute the support vector classifier. Okay. So CM. So from sklearn dot svm, import svc. Import the svc. Okay. Now what I will do next is I'll be initializing the svc. So m1 is equals to what? svc. After that, again, I will apply the cross validation technique. So using cross validation, what will I get? RES is equals to what? Cross val score on M1 X comma Y and CB equals to, this time let me take it as 10. So what are we getting? It's a fairly good accuracy in comparison. 75.78. Right. So let me add this to the list. So m.append. I'm creating these two lists so that towards the end, I can compare the different models. Okay. So m.append for vector machine s.append R. Now if I try to print it, I will have this. Logistic regression, decision tree, KNN, support vector machine, and these are their corresponding accuracy values. Okay. So if you want, you can also use train test script. Okay. So how to use? So what I will do here, I'll just show you how you can check the accuracy of the model using this. So we already have the training data split, right? So, yeah, this is our training data, X-train, X-test, Y-train, and Y-test. So I can use that information to uh, train the model. Either you can use cross-validation technique or you can use train test evaluation. So I have already done the cross-validation technique, but I'm also going to show you how to do it using train test. So I'll put the model name as what? K1 is equals to what? K nearest neighbors. K neighbors classifier. Number of neighbors is equals to 7. Then after that, I'm going to apply this model to the training data. X-train, Y-train. After that, I'm going to do the predictions using the train model. So Y-pred, that is the predicted results, will be stored here. And how am I going to get the predicted results? Using the model. Then I need to check the accuracy score. So print by comparing the Y-test and Y-pred. K1 dot, sorry, should be predict. So I have the accuracy value as 76.62%. Okay. Then I can also do what? The SVM model evaluation. So for SVM, I'll just write SB is equals to what? SVC. Now, this part is what? Generating the model. This part is training the model on the trained data. And this part is what? You are trying to test the model by seeing what it is giving you as the output by looking into the testing data. After that, you check the accuracy of the model by the accuracy score function. So I have the accuracy as what? 77.2. Okay, so these are the different ways in which you can use the different evaluation techniques. Now, we have compared what? 1, 2, 3, 4 models. Okay, out of these 4 models, who is at the leading? Who is leading? Logistic regression model is leading because all of these models I have compared using cross-validation technique. You can also compare using the train test evaluation. Okay. So based on the cross-validation technique, I am getting these 4 as the output. And out of them, who is giving me the highest accuracy? The highest accuracy is given to me by logistic regression. It is given to me by logistic regression. Okay. So it is leading. Let us try to, create some more models to see who is going to work best. So the next model that I'm going to create is this. It is the bagging classifier. So what is the bagging classifier? Bagging classifier is going to, bagging classifier is a machine learning model that has multiple base models. Okay, so we have built logistic regression, right? We have built a logistic regression model. Now this is a single logistic regression model. What bagging classifier is capable of, it is capable of taking multiple logistic regression model and combine them together. So instead of working with only a single logistic regression model, now you have 4 different logistic regression model who is working on the subset of data. Suppose from this entire data set, this part of the data is going to be used to train logistic regression 1. This part of the data is going to be used for logistic regression 2. This part of the data will be used for this. This part of the data is going to be used to train this. So it is having what? Multiple base learner, and each of these base model is learning on a different subset of the data. That means this model, this model, this model, and this model, they are learning differently. They are being trained differently. Finally, what happens is you are going to use the different learning process to see what is the output generated by all. Suppose there is a data point, there is an unknown data, and for this unknown data, all of these 4 models is going to generate some prediction. For this unknown data point, all of these 4 models will try to generate some predictions. And suppose this logistic regression 1 predicted 0, 1, 1, and this is 1. So what is the final output going to be? The final output is going to be the highly occurring data. So 1, 1, and 1. So the output is going to be 1. Final output is going to be 1. This is how bagging classifier works. Now, the thing is what? When this bagging classifier is used, it needs a base model. It needs a base model. So what have I used as the base model? I have used logistic regression. I have used logistic regression. Okay, so you cannot use logistic regression here, decision tree, SVM, and KNN like this. No, base model has to be the same. So if you are selecting logistic regression, that means multiple logistic regression model can be used in the background. Okay, that is how bagging classifier works. Okay, this is how bagging classifier works. So let us try and build this bagging classifier and see how it is behaving for my model. After that, we will check for the boosting. Okay. So for bagging classifier, we need to import the library list. Right, the bagging classifier. So from sklearn.ensemble import what? Import bagging classifier. Very good. So just wait for the prompt because you might not remember what is capital, what was small, right? So then it can, in that kind of situation, you can wait for the prompt. Import the bagging classifier. Now the thing is what do I want to use in the background? What model do I need to use in the background? So I'll use what? I'll use a logistic regression model in the background. So already I have imported the logistic regression model before, right? Somewhere before I have already imported it. I think, yeah. So here I have already imported the logistic regression, right? I don't have to import the same model again and again. But if you want, you can also import it. So this is going to create the bagging classifier model for it. But this needs a base model. So for base model, I am going to use logistic regression. So I am going to call upon the logistic regression. So from sklearn dot linear model, import logistic regression. Okay. So this is my base model. So I'll just write what? Base is equals to logistic regression. To specify max iter is equals to 700. Okay. Max iter means the number of training it needs. Okay. Max iter equals to 700. So this is currently an empty base model. I need to now fit this base model to the bagging classifier. So what I will do, I'll initialize the bagging classifier and then I'm going to specify the estimator as the logistic regression model. So bag is equals to what? It is going to be bagging classifier and estimator. It is asking me for the estimator, right? So estimator is equals to base. Estimator is equals to base and number of estimators. That means how many number of base models do I want? Number of estimators, I'm going to keep it as 100. That means at the background, there should be 100 base model running. Okay. So number of estimators, I have kept it as 100. Now using cross validation, cross-val evaluation. Now using cross-validation, I'm going to evaluate this model. So RES is equals to what? Cross-val score. Cross-val score on the bagging technique. Independent feature X, dependent feature Y, and number of folds, let me keep it as 10. Then the final outcome is what? R equals to RES dot mean. And let's see what is the outcome. So running multiple models, right? So it takes a little bit of time. So it took 39 seconds to run. R was not given to me here. So let me see what was the output for R. 77.08%. Okay, still less than the previous model of SVM. So let me just put this inside the list. Let me put it inside the list. So m dot append, that is what is the model name? It is the bagging classifier. It is the bagging classifier. And what is the score? S dot append. And now I'll just print the values and comma s to see whether they are successfully appended or not. So yes, logistic, decision tree, KNN, support vector machine, and bagging classifier. And these are their corresponding outcomes. So just give me a minute, everyone. Just give me a minute. Yeah, sorry about that. So this is how you can put up the bagging classifier. So let us try to evaluate the same model for the using the train test. So train test evaluation. Train test evaluation. So how do we do it? Train test evaluation. I'm going to recreate the same model. So I'll just write that B1 is equals to log. I cannot use this. I cannot use them directly again because why? Already I have applied this model to be trained on the data. That means this model, this base, they're already trained. So which means I have to again recreate an empty model. Okay. So I have to recreate the empty model. Now just check regression. So this is the base. And this is the main bagging model. So what is the base that I have used? Estimators. Number of estimators, 100. Then after that, I have to train this model. Train this model on what? On extreme, y train. After that, I will extreme, y train. After that, I will try to predict on the X test and store the result where? Store the result as y rate. Then I'm going to evaluate the performance of the model by checking the accuracy score. Y test, y prep. So control enter. What happened? Okay, should be max iter. So I got what? I got a very high accuracy in comparison. So 80.51, right? So using train test, bagging classifier is showing me an extremely high accuracy. But since in the list, I'm putting up all the models by comparing using cross validation, I'm going to stick to that. Okay, I'm going to stick to that. But using train test split, I'm getting bagging accuracy is 80%, which is the highest that we have obtained till. Okay. So this is how you can evaluate. So this is how you can check the evaluation metrics. Okay. So I'll just write it here. Base model. Now, whenever you are using a lot of models together to construct a model, which we have done in bagging. So what happens in bagging is in the background, you are using several base models to construct a full model. Okay, so these kind of models are called as ensemble because you are assembling a different models to create a full model, right? So this is known as what? It's an ensemble model. Ensemble model. And what you are doing here? Training the model. Testing the model. Okay. Oh, we can store it. We can store cross-validation and train test results in a list also. But what I am doing here is I am comparing multiple models. So model 1, model 2, model 3, model 4. So, and what is the evaluation metric that I'm using to store? I'm using cross-validation. I'm using cross-validation. Okay, but if I want, I can also start storing the train test results. Okay, so we can do that. Yes. So see here, if I start, where did the logistic regression go? This is the decision tree, right? So what I will do, I'll store this decision tree accuracy score as A1. Okay, A1. And A1 is for the this one. It is for the purpose of evaluating using the train test kit. Okay. So for this is the accuracy score in terms of logistic regression. So A1 is equals to accuracy score. And I'll maintain a list, separate list to store these results. Let's say I'm going to create a separate list called T. Let's call it as TS. Equals to, this is an empty list. Train results. Okay. So what is TS going to have now? TS dot append A1. Okay, so control enter. So I'll have to rerun this whole thing. Redo thing. Just copy paste it everywhere. I'll send you this file also. Okay. Every time it is going to otherwise keep my list as empty. So I have logistic done, recently done, reason, okay, let me run the full model. Run all. Yeah, doesn't matter. It is going to keep on overwriting that value, A1. Okay. So initially it's executed logistic regression. So A1 was for logistic regression. After that, when it is going to have decision tree, then A1 is going to be replaced with that value for decision tree accuracy. But at the same time, I'm storing this result in a list, right? So I'm not losing the values. Okay. You can give different names also. That is also fine. So where is it taking? Lot of time. Now if I try to check print M comma T. Sorry, just TS, right? M comma TS. See, I have this. So these are the accuracy scores. So see, these are the accuracy scores as per the train test method. Okay. TS is for the train test accuracy. Then S is storing the score using cross validation like that. Is this clear now, everyone? So towards the end, I'll put it inside a table so that it is comparable. Okay. So any doubts or queries still here? Anything you want to ask? So I'm going to reshare this file with everyone. So have you received the file? So whatever we have done today, I'm sharing with you the updated file. Have you received it? Yes, no. Okay. All right. Okay, share the data set. Wait, I'll share. Yesterday, I shared two data sets for the purpose of study, right? So one was the diabetes data set. The another one was the cancer data set, which you can later on practice. Resharing the files. Now can you download? Are you able to download all the files now? Okay. Okay then. If there is no questions for me today, I'll end the session here. Okay. Thank you, everyone. Have a